Now to test doubles. Test doubles are a pattern or a set of patterns for more sophisticated unit-driven, test-driven development, and they provide us with an infrastructure for possibly replacing some subsystems which may be challenging to incorporate into the unit test cycle. Test double is often used to avoid slow tests, or maybe to implement tests that wouldn't really be possible in the context of a unit testing environment. We've mentioned the idea of the SUT already, the system under test, which is the example, the application or API you might be trying to exercise. The test double pattern introduces the notion of a DOC, that is a depended upon component. So the idea really is that if we can't use a real DOC, that the real dependent component is not available or would be too hard to configure or maybe isn't written yet, then it could be simulated in some sense, and we could get on with testing our own SUT by a replacement dependent upon component or replacement DOC. Test doubles, the name comes from the idea of a stunt double. In movie making, you substitute the real actor with a fake actor who has limited abilities, let's say, but can implement a specific requirement for a given shoot or a take. So we use it largely to try and simplify our test cycle in certain circumstances, to avoid slow tests whereby some subsystem can't really be incorporated into a regular running test, or where some tests are untestable in the context of the unit test runners without some form of substitution. There are a number of variants. This diagram isn't showing a class diagram, although it looks a little bit like that. It's merely showing a range of options and that they're all possibly related to test double in general context. Dummy object, test dub, test spy, mock object, fake object are all distinct approaches in the general test double approach. We'll take a detailed look at just two of these. You can probably guess what some of the others are, and I'll leave you to look up the catalog itself to see more detail. Test stub and mock object. Test stub is the simpler of the two. Means merely replacing a real component, and that replacement is kept reasonably simple and generally returns constant values. Mock object, a bit more sophisticated. We're again installing a replacement for the dependent upon component, but in this instance the mock object may have to simulate some behavior or verify that some behavior has occurred. We'll look at some examples of these now in the coming slides. First of all, what is a test stub? Verifying logic is the key idea. We're verifying some simple logic from the SUT, some simple interactions to the dependent upon component, and the test stub replaces the dependent upon component and returns those values as constants effectively. Let's look at why we might use that, or how we would use that in this example here. Take a close look at this code for a moment. We've got a time display of some kind. We're asking the system for the current time as a HTML fragment, and we're hoping that it will return midnight in tiny bold text. Reflecting on that for a second, you can see that we're trying to test, does it turn the time of 0 hours into the string midnight in a HTML context. So our test is creating a display, retrieving the time in HTML and verifying it. Now clearly this is going to be a bit of a problem, because if it's relying on a system time, it'll only be right once, very briefly, and we'll have to possibly reset the system time on our test machine and hold it at midnight for this test to actually exercise the logic we're verifying. Not very satisfactory really. So this test, as currently written, probably can't be used or is too difficult to set up the test conditions for. If we use a test stub, however, then we would be creating a stub before we create the time display, installing the stub inside the time display object, and then performing our test and verifying that we're getting back the appropriate string. Let's take a look at that for a moment. So in this test, we've got a new clause in here, test provider stub, and we're setting it to be midnight, setting hours and minutes to 0. Once we've created our stub, we're then creating our SUT, the system under test, the time display object, and then crucially, once we've created a time display object, we are installing the stub into the time display object by calling set time provider. Now our system under test is going to be using a fake or a stubbed version of the dependent upon component, the time provider. When we now go about calling get current time, we would be expecting to get back the correct value if our test is running, because it'll be 0 or midnight, and we can verify that the string is returned as expected. So this obviously requires that time display does have the concept of a time provider, and once it does, then we're substituting the time provider with a stubbed provider. So we're not showing the full details here really, but you can see the general idea. Install another object to replace the dependent upon component, in this case the general purpose time provider, with a stubbed version, which is going to return, in our case, a constant value every time to verify a specific requirement, which is a midnight in tiny bold text. Here is the same test again. This time it's built using a Java library designed specifically for this type of testing environment. And in the one we're looking at here is using a library called JMock. It's a little bit challenging to read, but let's just take a closer look at it for a moment. It's close enough to the previous one, but there's been a few changes. First one you'll notice is here. Our mock object is generated by the mock library. So TP_stub is mocking the time provider class. Second thing we're doing is we're creating a synthetic time, and we're going to be installing that into the stub class. So we're making a time object here, and we are injecting a specific newly generated method into the class dynamically, and that newly generated method will return midnight as its value. Now, without going into JMock library in a bit more detail, it could be hard to read, but we're just looking for a general understanding of what's happening here. Then we're installing the stub inside our SUT by calling setTimeProvider, casting the stub to the time provider interface or class, and finally the test is running as expected. The only difference between this and the previous example is here we wrote a specific class, that is, we had to author a test provider stub class, which we had to create with constructors and metas and so on. Whereas in this example, our library is generating the class for us. We're mocking out the time provider class, and through introspection and various other tricks in Java, classes can be generated dynamically. It means there's a bit of extra work to generate the mocked method getTime. So there's a big long incantation there to not only generate the class dynamically, but in the dynamically generated object, create a method dynamically to return a specific value, midnight. But once we've done that, the test runs as before. Now, mock object is related, of course. It's a variant of test double, and it differs from test stub in that we are able to set more sophisticated expectations when we configure the mock object, which we can then verify if those expectations have been met, that is, the SUT has interacted as we expected with the mock object, which is of course substituting for the dependent upon component. So the key point about this pattern is that there is going to be a range of interactions between the SUT and the mock object, and when the test concludes, we are going to be trying to verify that those interactions have occurred as we would have expected. So that requires a little bit of work, and the code becomes a little bit more obscure. There's a bit of work to configure the mock object. Sometimes we've got to configure not only that specific methods are to be called, but the order in which they're to be called, or maybe the frequency, possibly. And then after we have installed the mock object and run the tests, we've got to go back to the mock object and see, well, did what we expected to occur actually occur? We've got to do all that in the context of a JUnit runner. This can be challenging to read and write, particularly languages like Java, which have a strong type system. We've got to acquire quite a bit of boilerplate syntax to be able to specify the unit test expectations. And this can somewhat obscure, particularly a four-phase test, in that if we're used to writing four-phase tests and we encounter four-phase tests in the context of mock objects, they can become challenging to read. If we're familiar though with the pattern in general, and of course we're also familiar with the four-phase concept, then we can start to make sense of them a little bit more clearly. Let's look at an example. Again, I'm going to use JMock as a library. We're not going to cover all the features of JMock. We're just getting a sense really of how this can look. The general sequence in which we have to go through is we create a mock object, we configure a mock object, we install a mock object into the SUT. We also set expectations on the mock object. That is, we're trying to specify what behavior that mock object expects to see. Now, all of this is in the context of the setup phase. So whereas previously our setup in the four-phase test was relatively straightforward, here it becomes possibly quite a bit longer than the actual exercising and verification. So we've got quite a bit of configuration, installation, and expectation setting. Then we exercise as normal, and then we've got verification. Sounds a bit abstract, but let's take an example. Pub subsystems, publish, subscribe, are very common. We've got some sort of publisher class, and it can have subscribers added to it. And then when that publisher class wants to send a message, we can call it publish, and the publish class will send the message to the subscriber. We're taking a very simple-minded approach here now, and we're saying that the publisher can only have 0 or 1 subscribers. Usually it's 0 to many, but let's just keep it simple for the moment. Publisher has 1 subscriber. Here we add the subscriber to the publisher. And then at some later stage we call publish, sending a message. And if the subscriber is available, we will send that message to the subscriber. The subscriber is specified as an interface. That is not as a class, but just an interface capable of receiving a message. Now, how could we test this? Bear in mind now what we're trying to do is test the publisher, not the subscriber. And the dependent upon component is a subscriber. We don't want to use any specific subscriber. We want to mock it. In JMock, we would do something like this. Include the JMock facilities, and we would create a mockery object. So in our test case, we would be creating a JUnit for mockery called context. Then we would have to proceed with our constructing, configuration, and installation. First thing we do is we create a publisher object. This is the system under test. And we would create a mock subscriber. And then we would add the mock subscriber to the publisher. So this is relatively straightforward. And you can see we're using the mock object being created here. That is, we're saying context.mock subscriber. Next part is setting the expectations. And this is where we are specifying what we would expect the mock object to, in this case, receive, or to be what stimulation it should expect from the SUT. Now, the syntax here looks a little bit challenging. Again, we're saying context, which is our mockery infrastructure, .checking. And then we specify a sequence of exceptions. And we're specifying those in using nested objects and using object literals. Don't worry too much about that for the moment. We're specifying that one of subscriber.receive should be called with a specific message. So this syntax, and most of these mocking libraries come with a variant of something like this, is how we're specifying the expectations. We're saying I expect the receive message to be called on subscriber, and that subscribe message is method is to receive the message object. To exercise the SUT, we just call publish, and then once it's been exercised, we're expecting the result to be verified. Now, in the mockery framework, and this is true of several of them, the verification is automatic. That is, there's no explicit step 3, that is verification. It happens automatically in the context of the context object we've created. So let's look at it again, maybe collectively. It might get a better picture of how it works. Let's look at it line by line here and see if we can make sense of it. First of all, this is the system under test. It's a publisher object. This is the one I'm going to be testing. Secondly, I'm creating a mock subscriber. That is, the subscriber object I'm creating isn't an actual concrete class that I've implemented. It's a mock generated by the mockery. Thirdly, I am installing the mock into the publisher. So I'm adding it in one of the methods that the publisher reveals. That's all straightforward enough, and we can see no major difference here from how we might normally have been testing this. Here's where we get into expectation settings. It's my test data, my fixture, if you like, message. And then in here is the rather obscure syntax we use to verify the expectations. New checking, new expectations, one of subscriber.receive message. Because of the nature of Java, it looks a little bit obscure because you've got to keep everything type safe. But effectively what we're saying here is I want one receive method to be called subscriber, and I want that message to be message, which is the string. Finally, we proceed with our stimulation, the actual test itself. We call publish, sending the message. And automatically now, the mockery library, the JMock library, will verify that that expectation has been set. That is, it will verify that the receive has been called, and it will verify that the message, the string message, has been received. If that doesn't happen, the test will fail at this point. So we're getting guaranteed execution. Now, setting expectations is facilities in JMock are quite sophisticated. We just use one of, But we could be more specifically, we could have said exactly one of, or at least n of, or at most n of. And between max and min, we can specify that specific methods should never be called. We could specify that some methods may be called but we're ignoring them, and so on and so forth. In other words, we have here, and these are all methods we can specify inside the expectations clause. These are all ways of verifying behavior. That is, setting behavior expectations on the mock object prior to the test being invoked. And again, to remind you, we've just exercised this one of, and these are all the others. So that's the test double patterns: fake and test, mock object and test stub. Test by, fake object, dummy object. You could probably have a read of those. You can probably guess from their names roughly what strategies they might be implementing. I'll refer you to one more source here of fairly advanced thinking about unit testing, and specifically on the role of mock objects. This was an influential book published about 4 years ago, Growing Object-Oriented Software Guided by Tests. Very interesting read, an award-winning contribution to the field. And it very much places a strong emphasis on using mock objects creatively, specifically building mock objects before the specific components themselves are built, and then gradually evolving the software guided by tests. The image on the cover here is of a garden, obviously. The analogy they're looking for is growing software as in gardening, as opposed to building software as in engineering. Well worth dipping into, and you can see 1 or 2 free chapters of it online. They're definitely worth browsing.